Hi, let us start with the next topic of this session, Unit 3 in Digital Electronics. And you all know I'm Kavita, handling digital electronics for you. And the topics to be covered in this session are JK flip-flop, and already I told you the flow for it, symbol, circuit, operation, and all the tables. Similarly, T flip-flop. So first let us start with the symbol JK flip-flop. So your input is J and K, and I'm going to work with a positive trigger. So I'm giving the symbol as a clock, and the output is Q and Q bar. You already know Q bar is complement of Q. Now let us focus on the circuit diagram. While drawing the circuit diagram, already we have seen SR flip-flop. So in SR flip-flop, how it is connected is, it is cross connected, that is output Q is connected to the input. Similarly, Q bar is cross coupled and it is connected to the input. In same way connected, okay. And it is a JK flip-flop, and we are going to give a clock. So let us provide a clock like this to it, similar to that of SR, okay. And let me name the inputs as J and K, okay. And let me connect it over here. So now it resembles similar to your SR flip-flop, which we have learnt in the previous thing. It will resemble the same SR flip-flop, okay. Now it will resemble the same SR flip-flop. So now what is the difference, you may ask? The difference is, just connect your Q bar to J, to nearby J, and connect your Q to K. Okay, so that is the difference. The only difference is you have an extra input to this NAND gate, Q bar, which is connected to J, and Q is connected to K. Otherwise it resembles more or less as that of your SR. So this is the only difference between your JK and SR. So now let us look at the truth table. Before this, let me recollect the truth table of SR. 0 0 no change. When 0 1, reset is 1, output is 0. 1 0, when set is 1, the output is 1, and 1 1 cannot be determined. It is not at all, it doesn't exist. So now let us look at the truth table of JK. It is more or less similar that of your SR. That is 0 0 no change. 0 1, that is when K is 1, reset. 1 0, that is when J set is 1, it is set. 1 1, this is the only different state in this. 1 1, it is called as toggle state. What do you mean by toggle? 0 will be changed as 1 and 1 will be changed as 0. If the previous input is 0, it will be changed to 1. If it is 1, it will be changed to 0. So this is the only difference between your SR and JK. So let me recollect. In JK, same as that of SR, only thing is you have to add one more input to J from Q bar and to K from Q, and in your truth table 1 1 will represent your toggle state. And now let us look at the operation. So you know your inputs are J and K. So previous input Q may be 0 or 1, we don't know. Q may be 0 or previously Q may be 1. So you have to check all the conditions. So when Q is 0, the possible combination of JK is 0 0 0 1 1 0 1 1. When Q is 1, the same possible combination 0 0 0 1 1 0 1 1. That is, I am analyzing this flip-flop keeping Q as 0 as well as Q as 1. That is the thing you are going to analyze. So first let me start with the operation JK00. So for J I am giving 0, K also I am giving 0, and Q is 0. So if Q is 0, automatically Q bar will become 1. Okay. So now let us, how to determine the output, let me explain. You know that NAND gate, in NAND gate the output will be 1 when any one of the input is 0. So you need not worry, if any one input is 0, definitely output will be 1. Okay. So what you are going to check is, wherever the input is 0, the output will be 1. So now clock, always assume it is 1, it is positive trigger. So let me assume in positive trigger state it is 1. J0, K0. So here if you look at J is 0, so naturally one input is 0, so the output will become 1. Here again K is 0, so one input is 0, so naturally the output will become 1. So 1 over here, and from here Q is 0, so Q bar is 1. So 1 and 1. 1 and 1. So the output will be 0. So let me recollect your NAND gate. 0 0 A B, Y is your this A dot B bar. So 0 0 0 0 1 0 1 0, sorry, 0 0 1 0 1 1 1 0 1 1 1 0. So when any one input is 0, output will be 1. Okay, if all the inputs are 1, output is 0. So now look at over here. here 1 and here also, here is 1 and here is also 1. So 1 and 1. So now the output will become 0. Look at here, 0 and 1. One input is 0. So definitely the output will be 1. So now also you are getting same 0 and 1. So the output does not change. It remains in the previous input same as 0 and 1. So when Q is 0, the output Qn plus 1, that is your next state, is also 0. Okay. So now, so Q is also becoming 0. So now let us start with the next condition, 0, 1. So what is happening in 0, 1? J is 0 and K is 1. Let me assume clock always 1. Okay. So you know already Q, let me assume 0. So naturally Q bar will be 1. So one input is 0. So naturally the output will be 1. Here K is 1, clock is 1, Q is 0. So now Q is 0. So when any one input is 0, the output will become 1. So here it is 1. So now look at 1 and 1. So the output will become 1 over here. And 1 is also coming over here. So 1, 1. So look at the NAND gate. So 1, 1. So the output is 0. Okay, here 0 and 1. So any input is 0, output will be 1. So you will be getting 1. Okay. So now the output Q is 0 and Q bar is 1. So what did you understand is when J is 0 and K is 1, the output is again Q is 0. Okay. Just look at the Q alone. Okay. So now let me check for the third condition, 1, 0. Okay. So J is 1, K is 0. Always assume K clock is 1. So now look at, so here Q bar is 1. So 1, 1, 1. So the output will become 0. So now here 0, 1. Okay, when any one input is 0, naturally the output will become 1. Okay. So now 0 and 1. Now look at here, 0 and 1. So the output will become 1. 1 and, so 0 over here and here it is 1. So 0, 1. So if it is 0, 1, any one input is 0, the output will become 1. So here the output is 1. Okay. And look at this, 1 and 1, the output will become 0. So first check with the first gate and then check with the second. Okay. So 1 and 0. So previous input was 0, but now the next output has become as 1. Previous output was 0, but now the next output has become 1. So what did you understand? After the operation, Q is equal to 1. So now look at, again come back over here. So when Q is 0 and J is 1 and K is 0, the output is 1. So when J is 1, it is in set state. Similarly, you can do the operation and check it out. When 1, 1, it will work as a toggle state. Toggle state in the sense, if previous input is 0, the output will be 1. So 0 will be changed to 1. Okay. Similarly, if you work out for all these conditions, you will get output and you can explain the operation. Okay. So 0, 0, no change. So the same 1 will come. K is 1, reset. When J is 1, set. When 1, 1, toggle state. So 1 will be changed into 0. Okay. So this table, we are going to next write it in a table which is called as characteristic table. So characteristics table, you should write this format: Q input Qn plus 1. Q represents your present state and your Qn plus 1 represents the next state. So in previous slide we have assumed no, Q is 0 and we have proceed over here. But in the next state, Q has become as 1. Okay. So Q is the present state and Qn plus 1 is the next state. Now write down the possible combinations. You know, Q is 0, 0, 0, 0. JK will be 0, 0, 0, 1, 1, 0, 1, 1. Q is 1, 1, 1, 1. J and K will be 0, 0, 0, 1, 1, 0, 1, 1. Okay, now just recollect the two table. 0, 0, no change. 0, 1, reset. 1, 0, set. 1, 1, toggle. So this you memorize and have it down. So 0, 0, no change. So same 0 will come over here. 0, 1, it is called as reset. So reset na 0. 1, 0, J is 1, K is 0. 1, 0, so it is set. 1, 1, toggle state. So 0 will become 1 and 1 will become 0. Okay, so before that, let me write down the truth table over here. 0, 0, no change. 0, 1 is going to be reset. That is, the output will be always 0. 1, 0 will be set. That is, output will be always 1. 1, 1 will be toggle. Okay, toggle already you know. Now 0, 0, 0, 0, no change. So same thing. 0, 1, it is going to be reset. So 0. 1, 0, it is going to be set. So 1. 1, 1, it is going to be toggle. That is, 1 will be changed as 0. Same over here. 0, 0, no change. So same 0. 0 1 it is reset, so 0. 1 0 it is set, so 1. 1 1 toggle, so 0 will be changed as 1. Okay, so you just compare and write down over here. It is no change, so you are writing same 0. Here if you compare and write down, it is 0 1, so it is called as reset, so it is becoming 0. Similar way everywhere. Now I have to derive the characteristic equation. So for that, what I am going to do is I should write down the sigma m terms. So now your sigma m terms over here is 0 0 0 0 1 2 3 4 5 6 7. Already you are aware of your K maps and you are well versed with that. So now we shall see how to solve it. Okay, so now when it is becoming 1 is in all these conditions, only in this 4 conditions, that is 2 3 4 6. Only in this conditions your output is 1. So just write down that is sigma m 2 3 4 6. Okay, so that I am writing it over here. Now using your K map, just group it. Okay, so once if I group it, join these two things, join these two things. If you join these two things, whichever is common, so q bar, and over here j, and over here q, and the other one is k bar. Okay, so now your equation will become j q bar plus k bar q. Okay, so this is your final equation, j q bar and k bar q. You already know how to solve it using a K map and write down the expression. Okay, so now let us start with the table which is called as excitation table. It is same as that of your characteristics table, only with some changes. That is qn plus 1, then you should write jk. So what are the possible combinations of q and qn plus 1? Maybe 0 0 0 1 1 0 1 1. Now for this you should write down the value of j and k. So now come over here. Okay, if you come over here, now look at the conditions where q is 0 and q of n plus 1 is 0. Q is 0 and q of n plus 1 is again 0. Okay, so now look at the value of j and k. It is 0 0 0 1. Okay, so it is 0 0 and the next state is 0 1. Okay, so now j is same 0, so note down j as 0, whereas k it is 0 1. So both 0 and is there, 1 is there. So you just represent this as don't care, because it is not constant, it is varying, so note down as don't care. If it is varying, just note down as don't care. Now try with the other one, 0 1. So here the input is 0 and here the output is 1. Similarly 0 and 1. Now look at the input. 1, j is same 1, so you can write down 1, whereas k is 0 and 1, it is varying, so note down as don't care. Now look at 1 and 0. So for 1 and 0, 1 0 1 0. So now look at this condition. It is 0 1 1 1. So k is 1 same, but j is 0 1, so it is don't care. So don't care and 1. Now for 1 1 you can just compare. So for 1 1, let me compare. So 1 is over here, 1 is over here, 1 1. So now look at the states of 1. 0 0 1 0. So